Well done for doing both A and B. That's good. C and D if you want. First of all, mechanics is not my strong point, but this is the A level I can see. So I can do the A level mechanics, but further maths mechanics, no, I can do the stats and the pure, but just to warn you, I can't do further mechanics. But this is just projectiles, so I'm all right with that. And you've done the projectile bit, it's just the maths for me to do at the end, which is best for me. So it says here, you see, struggling with C, so if you've proved B, it's just solving the equation. Maybe you've done this bit, but unsure it's giving you the right answer. Anyway, right, so I'm solving for alpha first because I've got this equation here. Now, I'm sure your calculator has a way of solving quadratics quite quickly. So I'll be popping that into my machine. Well, I've got equations mode and it solves polynomials of degree 2. So I'm going to do that, and what my calculator gives me is that tan alpha can equal one of two values as you'd expect, 0.1758, or and, oh, is it and really, but tan of alpha equaling minus 0.075. Right, this is a projectile for starters, so it's this angle here, remember, that we're looking for, this alpha that's being thrown. So it's going to be an acute angle, so we can pretty much rule out that negative angle, because if you remember cast, I think you did cast, the negative value would lie in cos and sine. So those are, that would end up an angle underneath, throwing it down, that's no good. And that one would be an obtuse thing, so it'd be shooting off up here. So that's no use. So we'll go to this one. This one will give me with cast. Again, it'll give me a silly one going off down the other end. I'm not interested in that, but I'll just get this acute one here. If you shift tan that, what you get is alpha equals 9.97 degrees. Right, so we've got that, and then u, we're just going to use part A to get u. So part A, we showed earlier, or you showed earlier, that u squared equals 3g, so that's 3, I'm taking it, we're using 9.8 times 9.8 over 5 times sine of 9.97 degrees all squared. Right, popping that in my machine. That gives me I think it's 196.14. Oh, that's u squared. So u square root that, and we get something like 14.0 meters per second. So we've got alpha and we've got mu. Let's put using. We've got mu. Right, part D. That might be slightly more tricky. Let's try that on a new page. Right, point D then. To be legal, the serve ball must land less than 18.4 meters from the server. Determine whether or not this is a legal serve. So you've got this little person, and they must be serving it from up high, because they're serving it at 2.5 meters high. That's taller than me and you. Well, me anyway. I think more you as really, because that's quite big. So they're doing this quite a shallow one. It's going past where it's meant to be a parabola, so it's meant to be an even function here, but it doesn't look like it. But then it hits the ground there. There's the ground. That ball hits here. Right, so we know that angle there, that angle alpha, is 9.97 degrees. We know at this height, I'll do this in a different colour, this here, there, the displacement in height is 0. So you know you change your SUVAT now, we have to do SUVAT up and SUVAT along. So if we do 2 lots of SUVAT, you might think this question, oh, I'm going to do horizontal SUVAT. We might also need vertical, so let's get that down. Vertical SUVAT. Your teacher probably maybe put a little X on to remind you these are horizontal. And the other ones are, well, T's the same for both. Won't bother with T. And S for vertical, Y. Right, so we know there is 0, oh no, it's me. There's 0 gravity pull on acceleration when we know it's been hit, but after it's been hit, there's no horizontal acceleration, so that's 0. The vertical acceleration is always minus gravity, which is minus 9.8 ms to minus 2. Won't bother units. We're looking for not when it's travelled, we might have to find when it's travelled, not naught from the vertical. We actually want to find, because it's got to drop to the ground. So it's actually the vertical distance we want it to travel is minus 2.5 meters if it's got to hit the ground. So this wants to be minus 2.5 meters. U, we now know all the numbers for U. That was 14. And because it's vertical, you're turning against the angle, so that's sine alpha, and alpha is 9.97. The other way around, isn't it? When you do turning through the angle, that one must be the cos one, so you can fill that in as well. 14 cos 9.97 degrees. What else do we know? We're trying to find the horizontal distance to see if that's over 18.4 or not. So that's the one we really want. But we don't know velocity and we don't know time. Now, in order to use SUVAT, we need 3 of these. And we only know 2. But looking over here, we know 3 of the vertical ones. So we're going to have to use a vertical equation to get me something over here so I can work out the S. Now what's common to both is the time. So can we think of a SUVAT equation where I can get the time here and then put that in that one? So my SUVAT equation I'm thinking about is S equals UT plus a half AT squared. That's in your formula booklet. And I'm doing it for Y. I can get the time that it hits this ground here, and then that will be substituted into there to find how far it's gone. So we've got minus 2.5 equals, if we work this one out, let's have a look if that's a nice number. I doubt it, but rid of that from my calculator. So I've got 14 sine 9.97, make sure you're in degrees. That gives me 2.43, no 2, I can't read, 2, oops, 2, 3, let's call it 86. It's a big number. So it's that T, I'm going to fit all this on, plus, actually, but if you plus, because it's might have 9 minus gravity, can I write minus? You put it down. Minus, that's gravity. So half of gravity is minus 4.9 t squared. So again, I've got a quadratic in t. Just write that out as a quadratic. I can solve in my calculator. I'll make that positive. So 4.9 t squared minus 2.42386 t. Oh, that's gone over there. That becomes minus. Oh, and that means that's minus as well, isn't it? So wait a minute, sorry, t, putting that in my calculator then, we've got, lost my pen, I've got t, so I'm not sure if this is recording now. Is it recording? Or maybe I'm recording, it's just not saying anything. Right, so put in 4.9 minus 2 thingy and that's giving me t equals 1.003 or t equals minus 0.508 seconds. Well, it's not going to be a negative time, so we can ignore that. Right, so we've got t now. So now I can put, because t is common to, that's time, isn't it? So time be common when it hits vertically, minus 2.5 meters, then it's going to, same for the horizontal. So we know that now is 1.003 seconds. So final step then, pen again so you can fit it on. So I want to do the same equation now because I want to find S, but for Sx, that's not very different coloured pen, Sx will equal Ux, so that will be 14 cos 9.97 times t 1.003 plus, now we said that gravity was 0 in the horizontal, so that's plus 0. All we have to do is this little sum. Let's see what that gives me. 14 cos 9.97 times by 1.003. That gives me 13.8 meters. So looking at that, that's less than 18.4 meters, hence serve was legal. That's it. Right, just in case you want that, explain why the particle may not be good enough to predict the flight of a tennis ball. That's because a tennis ball will spin. There'll be spin on the ball. Spin on the ball, which model doesn't take, which model does not account for. and actually the spin will affect the flight. I like to think of when you play snooker, all those people, you know, you can, if you just hit the balls, they should just run, but if you hit them at different angles and then they spin round, then you see that the white screws back and whatever. So in sport, modelling with projectiles is absolutely useless, because athletes learn how to spin the ball to make it do what they want it to do. But there we go. Right, hopefully that was helpful, and quite enjoyed it. A mechanics question I can do without the mechanics. All right, good luck. Bye bye.